Hello, everyone. My name is Roger Sidhu, and today I'll be presenting my research project titled Wi-Fi 6E Adoption Challenges and Opportunities. So this presentation explores how Wi-Fi 6E extends wireless capabilities into the newer found 6 gigahertz band, and how it's shaping our the future of connectivity in homes, enterprises, smart cities. So I'll walk through the key insights from a paper and covering its technical features like adoption drivers, real-world case studies, and also we'll be talking about the transition into Wi-Fi 7. So in this report, I have picked Wi-Fi 6 as the latest technology, even though Wi-Fi 6 is still out there. It's just that all the shortcomings and research content required for Wi-Fi 7 might be incomplete. So we'll be going over the Wi-Fi 6E. So Wi-Fi has become a critical part of our daily lives with more smart devices, remote work, and streaming services than ever. Traditional networks are struggling, especially in crowded environments. This is where the Wi-Fi 6E comes in. It's an expansion of Wi-Fi 6 into the newly opened 6 gigahertz spectrum, offering more speed, less interference, and better performance. This paper dives into both the promise and the practical realities of adopting the Wi-Fi 6E. So, evolution of Wi-Fi standards. So, talking about that, Wi-Fi has evolved through multiple generations. Earlier standards like 802.11b and G offered the basic wireless. Then we transitioned to Wi-Fi 4, which brought MIMO, also called MIMO. Wi-Fi 5 added faster streaming with 5 gigahertz of the bandwidth, the new band spectrum. And Wi-Fi 6 changed the game by focusing on efficiency using techniques like OFDMA and MU MIMO and target wake time. So for now, Wi-Fi 6E, which builds on by expanding the 6 gigahertz band, gives us more channels and less congestion, especially important in high density spaces like stadiums and large offices. And talking about what makes Wi-Fi 6E technically special. So it operates in the 6 gigahertz band, which is from 5.925 to 7.125 gigahertz. And that adds up to 1200 megahertz of new bandwidth. This is a big deal because it enables many non-overlapping channels, eliminating the interference we usually face in crowded networks. Wi-Fi 6E also retains all of the Wi-Fi 6 features. So features like OFDMA which splits up channels to severe multiple devices at once. 1024 QAM packs more bits into each signal, boosting throughput. MIMO supports more simultaneous connections, both uplink and downlink. And on the security front, WPA3 is mandatory. It introduces stronger encryption and features like simultaneous authentication of equals, making it safer to use, even on open networks. So, moving on to the next, what's driving adoption? Well, first, we have the demand. We are seeing more 4K, 8K video streamed online than ever before. Also, the introduction of VR into the networks. Online gaming is a big one, and cloud apps, which is also a quite big field in itself. So all of which needs fast, stable, low latency connections. Second, there's a sheer number of devices. The average home has over 25 connected gadgets, and workplaces have far more. The Wi-Fi 6E is perfect for these dense environments. In enterprises, digital tools, remote work, and cloud services all depend on strong wireless. In healthcare, Wi-Fi 6E can support real-time telemetry and high-res imaging. And in smart cities, 6E can power smart lights, traffic sensors, and public Wi-Fi, delivering performance and reliability on a large scale. So we know that there are many things which will be driving adoption, and what are the challenges that we face or will be facing? So first is the regulations. Not every country has fully approved the 6 gigahertz band. For example, US and South Korea allow full use of 1200 megahertz, but the EU only allows 500 megahertz. Countries like India and Japan are still evaluating the range that needs to be used. Second, the cost. Upgrading means buying new routers, access points, and devices. Because the 6 gigahertz signal doesn't penetrate walls well, we'll need more access points to cover the same area, which adds to the expense. Third barrier would be limited device support. Since some new smartphones and laptops already have built-in Wi-Fi 6E compatible and even Wi-Fi 7 compatibility, like the very brand new ones, top of the line. But most devices still run on the older Wi-Fi, so that's a lesser incentive to upgrade routers if your device can't even take advantage of the new technology. And and lastly is the awareness. So many people think that Wi-Fi 6 and 6E are same, but not realizing it's a massive performance jump that comes with the newer 6 gigahertz band. So we have a few case studies in our report. And looking at the real world example, so there's a El Orioles upgrade its logistics warehouse to Wi-Fi 6E to support automated inventory and analytics. Before that, they had poor coverage and slow connections. With the Wi-Fi 6E, they achieved faster speeds, lower latency, and performance for future upgrades like robotics and AR. Our second case study is Team Labs. A collaborative education hub installed 65 Wi-Fi 6E access points to support hundreds of students. The hardware eliminates lag, improved video streaming, and helped manage dense device usage with minimal interference. And then we have the enterprise providers like Aruba Networks have deployed Wi-Fi 6E across Fortune 500 companies to support hybrid work and cloud applications. They have seen real performance gains in high traffic areas like meeting rooms and office floors. These examples show that Wi-Fi 6E isn't just a buzzword, it's also solving real connectivity challenges. And moving on to the next section. So what is the market actually saying? According to IDC, Wi-Fi 6E device shipments are expected to pass 550 million by 2026. Through newer numbers suggested that this might happen even sooner. But in reality, actually, we have already surpassed 550 million by the end of 2024. So the actual number is way higher than these reports suggest. Gartner predicts that the 40% of enterprises will have adopted Wi-Fi 6E by 2025, especially in industries like manufacturing and healthcare. Consumer electronics are catching up too, like Samsung, Google, OnePlus, and even Apple. They're building the actual Wi-Fi 6E compatibility into their phones and laptops. And more of these devices, as more of these devices will hit the market, Wi-Fi home upgrades will accelerate, most likely. Smart city initiatives are also beginning to explore Wi-Fi 6E for public safety, traffic systems, and environmental sensors. So all in all, the tech is there. It just needs to be scaled. We just need more deployments out there to have it all available. And now moving on to the next, which will be future-proofing. Let's say the Wi-Fi 6E, naturally the Wi-Fi 7 will take over. So let's talk about the Wi-Fi 7 or 802.11be. So Wi-Fi 7 builds on Wi-Fi 6E, offering even wider channels up to 320 megahertz, introducing multi-link operation, where devices can send and receive data across multiple bands at once. It also supports 4096 QAM, which pack more data into each signal, increasing throughput dramatically, but only in environments with strong signals. Another big improvement in latency, Wi-Fi 7 is designed for ultra low latency, making it perfect for telemedicine, industrial automation, and even competitive gaming. So what's the good news? The good news is many Wi-Fi 6E devices and access points are forward compatible, which means upgrading to Wi-Fi 7 will be smoother than the password transition. So that's a very big cost saving in terms of the hardware. So talking about the recommendations for the report, so for organizations, the best strategy is phased deployment, starting with the high demand areas and expand gradually, um, and making sure that the IT staff and are all up to date, and also apply WPA3 security protocols for safe implementations. Manufacturers should focus on wider hardware support and ensure Wi-Fi 7 readiness is in new devices. And policymakers need to harmonize the spectrum regulation, because without the actual use of regulations, we won't be able to exceed into near bands of transitioning. And with all stakeholders aligned, adoption to Wi-Fi 6 can scale very quickly and lay strong foundation for the future. So to wrap up the report, the Wi-Fi 6E is definitely a major leap forward, bringing more bandwidth, less congestion, and higher security. Um, yes, there are some hurdles like regulation, the cost, and awareness, but benefits are clear. We've already seen positive results in industries ranging from logistics to education and to enterprise IT. With Wi-Fi 7 on the horizon, this is a perfect time to invest in next-gen wireless infrastructure. Whether we are an individual, a business, or a government organization, the Wi-Fi 6E isn't just the future. It's actually already here. We are just on the point where we need to scale it up. And thank you for watching my presentation. I hope I have covered all the aspects of the Wi-Fi 6E, and hopefully we'll have better technology move forward. Thank you.